This is Samsak, and in this video we're looking at the product and the quotient rule. So first of all, we will look at the product rule, as the product rule is used to differentiate two functions that have been multiplied together. And it has a formula, and this formula you need to know. And this formula is d over dx in terms of u times v is equal to v times by du over dx plus u over dv over dx. Now this will make more sense once we start putting it in some questions. So we have two questions below, and both of these are multiplication, and we have to differentiate them. So the first one says differentiate x squared and then ln x squared. And this is using knowledge from the previous videos in order to differentiate these functions. So firstly, what we're going to do to this question is split it up into u and v. So we can say that u is going to be equal to x squared, and then that is because x squared is going to be times by ln x squared, so that means v is going to be equal to ln x squared, which using the law of logarithms is also equal to 2 ln x. So that means that now we have to differentiate both of these. So that means that we can get du over dx is going to be equal to 2x, while as a dv over dx is equal to 2 over x. And that is because ln x differentiates to give 1 over x, as we saw in the last video. But this is always the form that you want to put it in, and it's a lot easier to work once you put it in this form. And we'll use this for the quotient rule as well, this form. So therefore, we have to put it back into this formula, v du over dx plus a u dv over dx. So we'll start with finding what v is, and v is going to be equal to 2 ln x. So therefore, what we have is 2 ln x and that is times by du over dx, so that is times by 2x. Then we have u times dv over dx, so that means that we're going to plus, and then we have x squared times by 2 over x. So that is essentially our answer, but now we have to just simplify it. So we can simplify this by changing this to 4x ln x and on this one we can cancel the x with the x there, which means that we're going to be left with plus 2x. So again, we probably could leave it as this now. However, what we're just going to be able to do to finally simplify it is take out a 2x. So that means we're going to have 2x there, and then that is going to be 2 ln x plus 1. So the next question is asking us to differentiate cos squared x. And again, we're going to be using the idea of trigonometric functions here. And both u and v are going to be equal to cos x, as cos squared x is simply cos x times by cos x. So u is there, and v is equal to cos x as well. That means that they're both going to differentiate to give the same thing. So du over dx is going to be equal to minus sine x That also means that dv over dx is going to be equal to minus sine x. Essentially, this means that it doesn't really matter what order we do, but it's good to follow it anyway for future examples. So then v times by du by dx, it's going to be minus sine x cos x and then by doing u dv dx, then we've got cos x minus sin x, so it's going to be the same thing, minus sin x cos x. That is therefore going to be equal to minus 2 sin x cos x, which we can simplify one more time by using those compound angles, and in particular the double angle formulae, to make this minus sine 2x. If you don't know about that, watch my video on compound angles, as that's just a way to simplify this. And there we are, that is the answer to that question there. So the next thing to look at is the quotient rule. And the quotient rule is used to differentiate two functions, u and v again, when one has been divided by the other. And this is when d over dx, and it will be u over v, and I'll put that in there to make it clear, u over v is going to be equal to v du over dx minus u dv over dx, and that's going to be over v squared. So now let's look at differentiating tan x. As this may look like it can't be the quotient rule used, as it doesn't look like something's divided by the other. However, when we look at the identity, we can change this to sin x over cos x. Therefore, we're going to start off by using the same thing as we did last time, and we'll say that u is going to be equal to sin x, as it's u over v. And then we'll say that v is equal to cos x. Then what we'll get is we'll get du over dx. And we can say that that is going to be equal to cos x. And dv over dx is equal to minus sin x. So therefore, we're going to put this into this, and we'll say that v du over dx, so that's going to be cos x times by cos x. So there we are, we have cos squared x. And then what we're going to be able to say is that minus u dv over dx. So dv over dx is minus sin x, and then we have sin x here. So that's actually going to be plus sin squared x. And that is because it's going to be minus sin squared x. Now hopefully we're seeing something already emerging here, and that is going to be 1, but we won't put that in just yet, as we've got v squared to do. V squared is cos squared x. So therefore, what we're going to get is we're going to get 1 over cos squared x. And using those reciprocal trigonometric identities, we know that that is going to be sec squared x. So that is how you prove that tan x, the derivative of tan x, is equal to sec squared x. It's good to remember that one because it can come up, but that is how you prove it if you need to prove it. So the next one, slightly more difficult in terms of the things we're using. We've got differentiate e to the 2x plus 3 over x cubed. So again, we're going to start off by splitting them up into u and v. U is going to be equal to ue tx plus 3. Then v is going to be equal to x cubed. Therefore, du over dx that is going to be equal to 2e 2x plus 3. If you don't understand how we've got that, watch my previous video on logarithmic functions and how you differentiate that. Then this is just simple differentiation for this one, so dv over dx we'll go to 3x squared. So therefore, we'll put it in, and that means that we're going to get v du over dx. So that's going to be x cubed, and then we've got the du over dx there. So that's going to be x cubed 2e 2x plus 3. And then minus the u dv over dx. So it's going to be minus 3x squared, and then e 2x plus 3. This is all over the x cubed, and that is v squared, and that is going to be x cubed, so that means that we're going to get x to the 6. Now it's time for a bit of cancelling, and in both of these ones we have an x squared. So what we're going to be able to do is cancel that. We're going to be able to cancel that just to make it x, and we're going to be able to cancel this and make it to the 4. What we can also do is each of them have an e to the 2x plus 3. That means that we're going to be able to take this out. So therefore, what we're going to end up with is we're going to be able to take this e to the 2x plus 3 out. Then that is going to be times by 2x, as that's what left. We have the x and we have the 2. Obviously it would be x cubed, but we've cancelled that with the x to the 6 on the bottom. So we've got 2x there. And then here we have minus 3e to the 2x plus 3. That's just going to be minus 3. Then on the bottom, we've got x to the 4. So after doing that manipulation and trying to simplify bits and taking stuff out, there we have our final answer. So thank you for watching this video, and see you soon. Bye.